Assalamu alaikum. Well, students, last time we talked about the simple harmonic motion and how it is performed, what kind of motion is it. And then we talked about some examples of it in which we took the mass attached to a spring and we said that a mass attached to a spring executes simple harmonic motion about its mean position. Then we gave some of its characteristics, like what is the time period, what is the frequency, what is amplitude, and what is displacement of it. Today we shall talk about a topic which is the second topic of this chapter 10, and this deals with damped oscillations. As you know, in the absence, if there is no absence and the mass was attached to a spring, this mass was attached to a spring, and when it was pulled towards right through a displacement x, it kept on vibrating about its mean position. In the absence of any frictional forces, this body will continue to perform simple harmonic motion about the two extreme positions and its mean position. It will keep on oscillating about its extreme position in the absence of a friction force indefinitely. But in practical life, some kind of friction does exist which forces the vibrations to come to a halt after some time. There are certain occasions in which you want the oscillations to stop. And when you desire a vibratory motion, an oscillatory motion to stop, then you put in some resistance force. So damped oscillation is that oscillation, that vibration which are forcibly stopped. So damping means putting in some resistive force into the system. A typical example that comes to your mind is about the shock absorbers of a vehicle. The shock absorbers of a vehicle, they are constructed in this way. There is a piston and which moves in a cylinder. On top of it is a spring which has been wound around it. Now when the car, suppose it goes into a pit, falls into a pit, the springs get stretched and the spring keeps going up and down along with the weight, and you do not want this vibration to continue for a long time. Therefore you make this oscillation damp. You try to stop this damping, this vibration, this oscillation in this shock absorber body, so that the occupants sitting in the car do not feel the constant movement of the vehicle up and down, up and down. Such an oscillation in the presence of a resistive force is known as damped oscillation. And what kind of resistive force? How do they do it? They put this thing, suppose this is a shock absorber, this is a cylinder and a piston, and you put this into oil, and this piston moves up and down in oil, and which oil tries to stop the motion of the piston coming down, up, and that is how it damped. So damped oscillation is that oscillation which is in the presence of some resistive force to decrease the amplitude. And if you draw a diagram of it, it will be of this form. This is the wave, and the wave starts dying down. As you see, it starts dying down. It starts from this. This is the mean position. The wave goes up and starts going down. The amplitude constantly starts decreasing, and at one point it becomes zero. So an oscillation in the presence of a resistive force is known as a damped oscillation. Now the next topic that we would like to cover is about the wave motion. So very interesting topic, and you must have observed. Last time I talked about this thing, wave motion. you must have noticed that a wave is a disturbance that travels through a medium. A typical example is, suppose you have a pile of books, stacks of books. All books are piled up, they are placed in this manner, and they are all in the equilibrium position. Suppose you give a push from here, a force F is applied, and you push it on this direction. This last book will fall down when this disturbance travels here. So what, all these books will not fall. You give a push from here, the last one falls down. So what has traveled through these books? What is that which has traveled, which has caused the last book to fall down? Although the force was applied on the first one, this is the disturbance that travels through a medium, and that disturbance is known as a wave. So what is a wave? A wave is a disturbance that travels through a medium and causes the particles of the medium to undergo vibratory motion about their mean position in equal intervals of time. So wave is a disturbance which passes through a medium and performs vibratory motion of the body of medium about their mean position. And remember, always a wave always travels with energy. It carries energy from point A to point B. An example can be there. Suppose you have bicycles standing just like this, one by side, and you give a push to one bicycle on this side, and the last one will fall down. This is because of the energy that has traveled from point A to the point B, from here to here. So wave is a disturbance. Now, what are the type of waves that you can come across in your life? The type of waves, there are two types of waves. Waves that require a medium to travel through, and waves which do not require a medium. The waves that require a medium, types of waves, let me write it down for you. So there are waves which require a medium. There are waves which require a medium, and there are waves which do not require a medium. Waves that require a medium for their propagation are known as mechanical waves. And waves that do not require me for the propagations are the electromagnetic waves. So waves that require a medium, should I write it down for you? Okay, the medium is required by mechanical waves. And which do not require are the electromagnetic waves. Can you give some example of waves that require a medium? Well, sound waves cannot travel from point A to point B without a medium. Sound waves require a medium for their propagation. So sound waves are mechanical waves. Similarly, if you throw a stone in a pond of water, waves start traveling from it. These waves are mechanical waves. They cannot travel from the point of impact of the stone outwards unless there is a medium in it. And waves that do not require a medium for their propagation are the electromagnetic waves, and they are the microwaves, the radio waves, etc., etc. These are the waves that do not require a medium. sunlight from the sun comes to us without a medium in between, and they are also known as electromagnetic waves. So going through it, waves, what are the categories? Two categories. One that require medium, one that do not require. Second, one was required medium are the sound waves or the ripple times waves, and the which do not require the sunlight or radio waves, mechanical or radio waves, microwaves, infrared rays, they don't require a medium. Ultraviolet waves, they don't require a medium for the propagation. Now, what are the types of mechanical waves? There are certain types also of mechanical waves. Types of mechanical waves. There are two types of mechanical waves. A mechanical wave is that which requires a medium. And what is a wave? Is a disturbance that travels through a medium. And mechanical waves is the wave in which the particle or medium vibrate to and fro about their mean positions. Now there are two types of waves. One in which the particles of the medium vibrate longitudinally, and the second is in which the particle or medium travel at right angles to the direction of propagation of waves. The longitudinal wave is that wave, sound wave is a longitudinal wave. Longitudinal wave is that wave in which the particles of medium vibrate to and fro about their main position in the direction of propagation of waves. Example: when sound waves travel through a medium, it produces compressions. It compresses, the disturbance of sound compresses the particles of the medium, and this compression is formed, but this compression is formed at the cost of air which is pulled from here or from here. So a rare fraction occurs in the adjoining layer of air. And again, when this tries to get filled up, a compression is again formed, and then a rare fraction is formed. So what is a longitudinal wave? A longitudinal wave is that wave in which the particles of the medium vibrate about their mean position in the direction of propagation of wave. If the wave is moving in this direction, then the particle gets compressed here, and rare fraction occurs, compressed here, rare fraction, and in this way the disturbance travels from point A to point B. There are other examples also. Suppose you have a slinky. I'll drop this thing off and then let you know about longitudinal waves. We take the example of a small spring. This is the spring. It is called a slinky, S-L-I-N-K-Y. We take a spring and we attach them to both of its ends to two supports. Now, if you compress this from the center, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you slightly pinch it from the center, you will find a disturbance will start traveling from here, and this place from where you made the pinch, it will start traveling and reach the other end. And this is an example of a wave, a longitudinal wave traveling along the direction of propagation of waves. and the disturbance is also going on with it. So, what is a longitudinal wave? A wave in which the particles of medium vibrate to and fro about their mean position in the direction of propagation of wave. The wave is going in this direction and the particles of medium are getting compressed in this direction. There is another kind of wave in which the particles of medium move at right angles to the direction of propagation of waves, and such waves are known as transverse waves. Again, if you take a slinky and take a slinky, okay, and you pull it from here, you will see that the disturbances start now. In this direction, the wave is traveling here and the particle of the medium has been pulled up. You pull it up like this, you will see that the wave will travel on this slinky and reach the end. So, a transverse wave is that wave in which the particles of the medium move in a direction which is perpendicular to the direction of propagation of wave. Such kind of waves are known as transverse waves. Transverse waves, types of longitudinal, transverse. Before I start the next topic, which is about the waves as carrier of energy, I would like to go through the previous portions just to recapitulate. What is a damped oscillation? A damped oscillation is that oscillation which is in the presence of a resistive force. Whenever there is a resistive force introduced into an oscillation or vibration to reduce the amplitudes or to finish the oscillations, it's known as damping. Example of shock absorbers. Waves motion. A wave is a disturbance that travels through a medium. The categories of waves are two. One which requires a medium known as mechanical waves, and the second which do not require a medium, which are electromagnetic waves. Mechanical waves are the sound waves or the waves produced in a pond of water when you throw a stone. And waves do not require a medium, like electromagnetic waves, microwaves, radio waves, infrared rays, ultraviolet, sunlight. These are all examples of electromagnetic waves, and these waves do not require a medium for their propagation. The types of mechanical waves are two. One is known as a longitudinal wave, and the second is known as transverse wave. A longitudinal wave is that wave in which the particles of the medium vibrate to and fro about their mean position in a direction which is perpendicular, which is in the direction of propagation of waves. So what are the longitudinal waves? In which the particles of the medium vibrate to and fro in the direction of propagation of wave, and or in the way in which they move parallel to the direction of propagation of waves. A longitudinal wave and transverse wave is that wave in which the particle of medium move to and fro in a direction perpendicular to the direction of propagation. Next time we'll study about the waves as carriers of energy. Thank you.